Hey everyone, welcome to NCEES FE exam series. Here now in this session we are going to solve some problems on our subject dynamics, and the topic of discussion is going to be the projectile motion. It's a very interesting as well as the important topic for your NCEES exam. In this dynamics, as you all know, that we have the particles and rigid body kinematics, linear motion, angular motion, mass moment of inertia, impulse momentum, and work power energy, and dynamic friction, as you can see, and the vibrations. All these topics are important, right? You may get a question from any of these topic in your exam, and you can expect 9 to 14 questions in total from this, right? Okay, so in this session we will discuss about the projectile motion. So what is the projectile motion, that I will tell you, and we will solve some questions. First we will cover the concept, then we will solve some examples, as well as I'll give you some homework question, or you can say assignment problems, so that you can try those questions all by yourself. And if you need any help, if you find any difficulty, you can just contact us on this WhatsApp number. If you need any session for your preparation, you need any doubt clearing session, just contact us on this WhatsApp number, and we will help you in that. Okay, so dynamics, projectile motion, as I said. So first thing that you should know is how to resolve a vector into its horizontal and the vertical component. For example, if you have this vector and its magnitude value is r, so let's represent this vector as r vector, and it is making some angle, let's say theta, with the horizontal. So here theta is the angle made by this vector having the magnitude value r with the horizontal, and this is your vertical line, let's say. So here the horizontal component of this vector, right, that you can represent by rx, is going to be r cosine theta, and the vertical component, which is in this direction, is represented by, let's say, ry, and its value will be r sine of theta, right? So because you can form this in a triangle, this right angle triangle, this horizontal component, because hypotenuse length is already known to you, so the horizontal component will be of magnitude r cosine theta, where theta is the angle made by this with the horizontal axis, right? Okay, so you must remember these things. R cosine theta and r sine theta are the components, right? Vector components. Okay, so the projectile motion, actually, for example, if you have a football, right, you throw a ball, it will trace a path like this, right? This parabolic path is our projectile, right? For example, if there is a hunter having a gun and shoots a bullet from the gun, the bullet will go like this. It will also follow this projectile path, which is parabolic path here. Bullet will not go like straight, and no, it will follow always this parabolic path. Okay, now it depends on the initial velocity that we are giving to the bullet, that what will be the horizontal range and what is the height in that. Okay, maximum height, horizontal range, right, at which point it will touch the ground. So that is our topic of discussion in this projectile motion. So for example, as you can see, let's take, there was a body here, and we provided an initial value to it, v naught. Initial value v naught is the initial velocity which is provided to this body, is projectile in this direction. Okay, so it will follow this path. Let's say theta is the angle made by that velocity vector with this horizontal level here. Okay, so you know two things, initial velocity as well as theta angle. Okay, so the equations are already given in your handbook. These are the equations that you are going to use. I will explain them one by one. First is ax. What is ax? It is the acceleration in the x direction, or horizontal direction, you can say. Actually, we are not providing any acceleration, or we are not providing any other external force. Once the body is thrown out, once we kick the football, we are not providing any other extra force to it. So there is no external force, and hence I can say there is no acceleration in the horizontal direction that we are providing to it. Okay. Similarly, we have ay, that is equal to acceleration along vertical. So if you throw a ball, if you have something, it will always be attracted by the center of the earth. Why? Because of the acceleration due to gravity. Actually, acceleration due to gravity is in the opposite direction this time, right? We are considering our direction as upward. But here, the earth is attracting that body towards its center due to this acceleration due to gravity in the opposite direction. That's why we are using a negative sign. So, is it clear? It is always 0 for, means you can say the vertical acceleration is always minus g. Now, next is Vx, which is velocity component in the horizontal direction, which is V naught cos theta. If you have a body, this is your V vector, as I said. The vertical and horizontal component you need to know, right? So if this is the V vector, the V naught, you can say theta is the angle. So the horizontal component of the velocity will be V naught cosine theta, and the vertical component will be V naught sine theta. So here are those vertical component as well as the horizontal components, right? So this is your horizontal component, which is V naught cos theta, and this is your vertical component. What is that? Vy is equal to V naught sine theta, as well as I said, the earth is also attracting that body, right? It is also attracted towards the center of the earth. So due to that, there is velocity. This part is also added extra to that one, right? This velocity is due to the acceleration due to gravity, which is in the opposite direction. That's why we are using the negative g. Okay. Next one is x. What is x? It is the horizontal distance covered by that body, right? For example, body starts from here and it moves this distance, right? The total distance is the range, or you can say horizontal range. But if we want only this part, means after, let's say question says after 10 seconds where will be the ball. So for example, after 10-second ball is here, it is not reaching the ground at that time, so it's here, let's say. So in that case, this distance will be our x distance after 10 seconds. And y is vertical distance. Again, this is the formula, this vertical height, right? There is a point at which the height is maximum. Here it is h max, you can say height is maximum. But in the question, if this is find the height after the 10 seconds, so maybe ball is going like this, and after 10-second ball was here, so this is your y in that case. Okay, so I hope you get all these things. What is the value of a now? Ax, vx, x, ay, vy, and y. Okay, acceleration due to gravity is to be keep in your mind, right? That is always there in the opposite direction. That's why we are using minus g, and the value of g depends on what value you have to use. If the question is given in terms of feet, then you have to use g as 32 feet per second squared, right? Generally, we will be provided question in terms of feet. If it is not in feet, like it is in meters, so then you have to use 9.8 meter per second square accordingly, right? Okay. So let us move to the questions. Here is the first question. An object has horizontal speed 20 feet per second. So question is in feet. Okay. It leaves the surface that is at 10 feet above the ground. At what distance x will be the object hits the ground? So ball is here, which is at a 10 feet height already. So it's already there, right? Height is already there. So you can say the y in the given equations, this y naught is already given as 10, right? Here, if the ball is thrown from this point, then y naught is 0. But in our question, some height is there. So this time in our question, y naught is already given as 10. So ball is going from here. So it will go like this. Okay. Now, here it is with the 20 feet per second. So ball will go like this. It will trace a path, projectile path here. Okay. And the question says, what is the height? What is the distance here? X, when ball or that object hits the ground, that you need to find. Okay, so let's find the value of x. Okay, so what is given to us? Let's write all those things. V, initial velocity, v naught, let's say, that is given as 20 feet per second. That is given to us. And what is the angle? Theta. Actually, you have the ball here, and you are not providing it any other external force or something. So ball is going directly initially with this. Ball is going this line. So the angle that this velocity vector makes with the horizontal line is 0. There is no angle, so 0. Okay, so we have the Vx value. We can easily calculate the velocity component in the horizontal direction and Vy also in the vertical direction. At the end, we need the value of x. Okay, where y naught is also given as 10. So this is the information that is given to us, and we need to find the value of x. Okay, so let's use the equations here. First that I am going to use here equation is to find the value of t, I will use the value of y, right? Last equation, which is y is equal to minus gt square by 2 plus v naught sine theta t plus y naught. And we already know that y naught is 10 units. So I will substitute that here. Theta is 0. So sine 0, 0. Sine of 0 degree is 0. So this part is no longer required. What you are left with is y is equal to, where g I will use as 32, right? The value of g will be 32. So y is what? At the end, see, I want to find the time when ball goes from here to this point, at the end point here. So what will be the height at the end? 0. The value of y is 0 at the end. So I will take this as 0. So what we are left with, we will get an equation in terms of t only. Okay, so when I substitute those values, I will get 0 is equal to negative 1 by 2 times 32 times 2t square plus 0 plus 10, right? Now using the calculator or directly calculating this value, right, we can easily calculate this value, gives 16, and from there we get the value of t as 0.79, right, the square root of that quantity, square root of 10 by 32. That gives us the value of t is equal to 0.79 seconds. So it means the ball, this object, will hit the ground after 0.79 seconds. Okay, now we need to find the value of x. So using the second equation, if I go back to my equations here, x is equal to v naught cosine theta t plus x naught, right? And we already know everything, right? We know the v naught value, which is initial velocity. Theta angle is 0. I will substitute the value of t and I will substitute the value of x naught. X naught is initial distance covered along x direction, you can say, which is also 0 for that question, right? There is no extra distance covered by the ball. For example, if they says that let's go back to that part. Okay, for example, they says ball was here initially and it rolls from here to here, so it covered, let's say, some extra distance, say 10 feet. In that case the x naught will be 10, but here ball is starting from this part only, there is no other horizontal distance covered. So I can say x is equal to v naught cos theta t plus x naught, where x naught is 0. We already know that value of t, which is 0.79. The theta value is 0. So cosine 0 is 1 and v naught is already given as 20. So I will substitute those values in this expression. I'll get x is equal to 20 times 0.79 seconds, and that gives me the distance or the horizontal distance covered as 15.8 feet. That is our solution at the end. Okay, so the object goes like this, hits the ground after 0.79 seconds, and this horizontal distance is 15.8 feet. The height was 10 feet already given to us. So that's how we have to solve these questions. You must know the initial velocity, the angle that it makes with the horizontal direction, horizontal axis, you can say, right? Initial velocity should be known, x naught and y naught. means initial distance is covered in along x-axis or initial distance is covered along y-axis if there is any. Okay, so let's take one more question. Here is the question. An object is traveling at a velocity 30 feet per second and leaves the surface at an angle 15 degree. This time the angle is there, right? This time the angle that this object, right? The velocity, the angle that the velocity vector makes with the horizontal axis, this time it is like this, is our V naught. So this angle is 15 degree given to us. So you can use the scientific calculator to calculate the values of cosine 15 and the sine 15 degree. That's very easy for us. So what information is given to us? Let's rewrite it. We have V naught is equal to 30. Also we have the angle theta as 15 degree. And Y naught, this height is 15 feet. Okay, so Y naught is 15 feet. X naught is 0 because again the ball is starting from that point only. That object is starting from this point only, A point, let's say. There is no other horizontal distance covered before that. So it's here. Again in this question we have to find the distance x. So ball will go like this. Okay, it will again follow this parabolic path. So we need to first find the value of time after which the ball hits the ground, right? So let's find the value of t using the same set of equations. First I will use the y, right? First I'll be using the y, which is minus gt square by 2 plus v naught sine theta t plus y naught as given from the equations. Y naught is, as we know, 15. Theta angle is also 15 degree. V naught is already given as 30. G I'll use as 32. So Y at the end, if ball reaches the ground, what is the height? 0. 0 is equal to minus 32 t squared by 2 plus 30 sine 15 degrees plus 15. Okay, so using this we need to find the value of t, and when we solve it you can use the calculator to get the values of sine 15 degree and calculate it, and at the end you will end up getting t is equal to 1.24 seconds. Okay, so I'm using it directly using the calculator. So you will get the value of time is 1.24 seconds. After 1.24 seconds the ball will hit the ground. Okay, now let us find the value of x. Again I will use the same equation which says x is equal to v naught cosine theta t plus x naught. So v naught is what? Again the v naught is 30, theta is 15 degree, time, this time we know the time, that is 1.24 seconds. Time is already known to us, plus x naught. There was no initial distance covered in x direction, so that's why x naught is 0. So you can use these equations and you will get the value of x from this expression. Okay. So when I solve this, the value of x after substituting these values in the calculator, I will get the final value as 35.9 something feet. So as you can see, we need the nearest, right? It's not the exact value, but we can say the nearest value we can say is 36 feet. Option C is the correct answer for that. Okay, so you can easily use the equations which are already provided to you in the handbook to solve the questions on the projectile motion. Here are the equations. You only need to know what is AX, what is VX, what it represents. Okay, so you need to know your handbook, right, as well as your calculator. That is also important. Okay, so here that's all about the projectile motion, how the ball goes down or touches the ground, right? Sometimes it is kicked from the ground and it follows that parabolic path, but projectiles always follow the projectile, right? Like this. Trajectory will be parabolic. Okay, so that's all about this projectile. I hope you learned this from the session, and here are the 4 questions that I'm giving you as a assignment. You need to try these questions by yourself. Try these questions, and if you find any difficulty or have any doubt, you can just let me know. Feel free to contact us on this WhatsApp number or join our Telegram channel. Don't forget to subscribe our channel. Keep watching, keep learning, and I'm here to help you in your NCEES exam for all the chapters and all the topics. Okay, so thank you for watching. See you in the next part. You can also take the screenshot of this page so that you can solve these questions by yourself. This is in the black and white version, so it's inverted part actually. So you can take the screenshot, you can have the print of this. Try to solve the questions. I'll meet you in the next session. Thank you for watching. See you in the next part. Keep watching, keep learning, and if you need any help, you can just contact us on this number.